today we'll look at some examples regarding the energy and conservation of energy. So the first example will be a pendulum. So in the pendulum itself, we assume that this pendulum is an ideal pendulum. That means there is no friction and no air resistance. So such that there is no energy loss to overcome friction, there's no energy loss to overcome air resistance. It is ideal, it's in the perfect world. Okay, so what happens here is the pendulum is our original position at 1, then it moves on to the position 2 here, which is at W. At W here, it has a certain height above. So since it has a certain height x, what energy does it have? Yes, it has a gravitational potential energy. Okay, since it is also at W and it is being brought up there, does it have any movement when it's at W itself? No, no movement means it does not have any kinetic energy. So it only has GPE. Next, so that was what happens. So 1, it went to 2, and then it comes back to 3. So what happens is this: when it's raised, the pendulum is released from W. So when you release from W, it swings back towards Y. So this is where it's at point 3. Okay, so now when it swings back to Y, it is point 3, which is the original position when it was at rest. What happens next? This place here at W, just now we mentioned, it has GPE. Okay, does it have KE? No KE, because it is stationary, it is being released from there, it only has GPE. Now let's come to W here itself, GPE and KE, let's write these two. Does it has a GPE? Does it have any height above the ground? No, so it has 0 GPE. And what happens to the KE? In this case, the KE will be called as maximum. So GPE is at a minimum, or in this case 0, while KE is at the maximum. Okay, so now we are at point 3. So along the way, what happens is the gravitational potential energy at point 2 or at W is changed along the way such that the pendulum starts to move. When it move, it converts into kinetic energy. Okay. So what happens next? From Y at 3, so is 1, it went to 2, and then it come back to 3. Now it goes to 4, which is at Z. From Y, the bob now swings upwards to the other side. It now loses KE and gains GP. So what happens now is it loses the KE. Why? Because it starts to move up, then it slows down, so sometimes it stops. So at point Z here, let's put down the 2 energy. It does not have any more KE because it slows down, and it gains all into GP. So at point Z, because it has a certain height x, it only has GPE. In the ideal case itself, the bob will swing up to Z at the same height as when it is released. So this whole thing itself is what we call as the conservation of energy. Energy is always converted from one form to the other, and it's always interchanging from one to the other. It is not lost, it is not created. Okay. Now what happens when okay, let's summarize for the ideal pendulum first. So in summary, this is what is happening from W to Y. Here at W, we start here first, then you go on to Y. It has GPE. Okay. At Y itself, it has no GPE, it only has KE. Okay. Now from Y to Z, what happens here is from Y, it has only KE. Remember, it has maximum KE at Y. And then it goes back up here where it's not moving again, and then it has GPE only. No energy is lost or supplied in the system. It keeps changing from GPE to KE, KE to GPE, and it keeps swinging and swinging and swinging non-stop, and it will never stop. Now, next, what happens is in the real world? In the real world itself, there is energy loss. Why is there energy loss? Because there is friction and there is drag forces. So there is a force that will use some of this energy. So the total energy of swinging the pendulum will be converted to thermal energy. So some of the energy is converted into thermal energy. Okay, why thermal energy? Because when you rub against the air, the wind itself, it heats up. So this thermal energy will be lost to the surrounding. Dissipated means lost to the surroundings, and cannot be converted back into kinetic energy and GPE of the pendulum. So the total energy is still conserved. So what is happening? Let's look at the example here. We start off with W to Y first. So from W to Y. At W itself, it has GPE, we all know. KE is 0. Why 0? Because it is not moving. We bring it up there and hold. Next, we release it. It starts to move. It converts into KE a bit, converts a bit more, and then it converts to full KE. Okay, it converts into KE. Now, at Y itself, when it's at y, some of the energy is also being converted and lost due to friction. So some of the energy is lost due to friction or air resistance. Okay, so let's say if GPE we have 10, your KE is 8 at y, some of the energy of 2 joules will be lost to friction. Now let's move from y to z, from y to z. So at y, we know that we have KE. Okay, this KE is a lesser amount of energy as compared to the start already because we lost some due to energy here. Okay, now it's brought up to Z, and it has GPE. Now at Z itself, if you realize the height is lesser, it is less height as compared to the start. Why? Because energy is lost. Where did the energy lost to? Energy is lost due to friction and air resistance again. So as you can see, what happens every time it moves, energy is being lost due to friction or air resistance, and it moves again, it loses due to friction and air resistance. It keeps losing until it comes to a stop. So what happens? The final kinetic energy at y and the final GPE at z are lower than those in the ideal pendulum. So the question will be, did they lose any energy? No. So the question will be, is the principle of conservation of energy being obeyed? Answer is yes, because although the energy is being lost to friction, we can account for it in this whole system itself. That means energy cannot be created or destroyed. It is only converted from one form to the other. And in this case, the energy at the start is being lost to the energy due to friction. Okay, so we know where it goes to. The total energy is still constant. No new energy is created. No new energy is destroyed. The energy only changed due to friction. Okay, so with that, we will end here for today before we come back with another example.